We've touched on multiplying and dividing expressions with exponents in the past, but today we're going to look at it a little more in depth. Consider the expression, oops, I didn't mean to do that, 3 squared times 3 to the third. Well, we know that 3 squared means 3 times 3, and 3 to the third means 3 times 3 times 3. So I have 1, 2, 3, 4, 5 of these multiplied together, making it 3 to the fifth. It's pretty clear here that a shortcut would be to say, if I'm going to multiply 2 3's together and 3 more 3's together, and I'm in the end going to be multiplying the 5 3's together. We'll go on to then say that that means that it's 3 to the fifth power, which is 243. Similarly, if I have negative 3 to the second power times negative 3 to the third power, the same thing holds true. I could expand it, write it accordion style, and if I take the time to do all that, these first one is negative 3 times negative 3, and then I've got negative 3, negative 3, negative 3. Well, you can see that it's much faster to realize that this is going to be negative 3 to the fifth power. And I know that a negative number raised to an odd power is negative. And I also know from up here that that is 243. So this is negative 243. By the way, I hope you do remember from our conversation in class how to use calculators to raise numbers to powers, because these can get pretty big. All right, so clearly when I am multiplying expressions that have the same base, meaning these are all 3's, I can add the exponents as a really handy-dandy shortcut. Then we'll write it all down. What if I have 5 to the fifth power, sorry, that doesn't look like a 5, 5 to the fifth power, divided by 5 to the third power. As I said before, this should look familiar because we've done stuff like this. I've got 5 to the fifth power means 5 times 5 times 5 times 5 times 5. And this, down on the bottom, is 5 times 5 times 5. Actually, let's make it 5 to the sixth, since that's so sloppy anyway. And from this I can see that 3 of the 6 will cancel out, leaving 3 on the top. So that is 5 to the third power, and 5 to the third power is 125. A shortcut for here is to say that if 3 of these are going to cancel out, I will be left with 3 others. So really what I'm doing here is subtracting the exponents. If I'm subtracting 3 from 5, it gives me 5 to the third. The same will happen if I do negative 5 to the sixth power. It has to be the same base, though. Negative 5 to the third. By base, I mean this number. So this means negative 5 times negative 5 times negative 5 times negative 5. Ooh, this is big. Times negative 5. And I'm dividing that by negative 5, negative 5, negative 5. Since these are all multiplied together, I can drop out the ones. What did I do wrong? Oh, I don't have an X here. 6. I can drop out the ones. And this equals negative 5 to the third power, which, as we know, a negative number raised to an odd power is negative. So that's negative 125. I will say in some of the source that we're using, they use this symbol, 8 to the seventh, divided by 8 to the, third. This is still divided by. It means the same as a fraction bar. It's really kind of outmoded in 7th grade. We don't use that so much, but it means the same thing. We're still dividing, so this is still, whoops, this is still 8 to the 4th power, which, in case you're curious, is 8 to the 4th power is 4,096. So, in a nutshell, to put multiplying, oh, boy, I'm really sloppy today. When multiplying expressions with the same base, I hope you know what that means. That means 2 to the 5th. 2 is the base, 5 is the exponent. We can simply add the exponents. And in case you ever forget this rule, just do a problem out. When dividing expressions with the, oops, I wanted to do that in red. I like this idea of, it won't let me erase. Gosh darn, I'll just have to underline. When dividing expressions with the same base, you got it, you subtract the exponents. This makes perfect sense because multiplication and division are opposite or inverse operations, so it makes sense that we would do the opposite or inverse operation with exponents. Let's just do a few examples. We've already done some, but actually I think we've done enough. You all got some good practice in school, so